So welcome everybody to this rather hybrid video on iterative processes, and this topic is linked with both GCSE and also at A level. Now in this video we'll be going over the types of iterative sequences you can have and also ways of describing them. Now an iteration or sequence can either do one of the following types of things. So the first thing it can do is what we call converging. Now this is when the value of the term in the sequence or iteration tends towards a particular value. So for example, if I was to draw, let's say, a diagram where our vertical axis is un and we had n, so if a sequence or iteration converged, then basically what it does, it starts at a particular value, but then it would tend towards becoming 1 as n increased. Now obviously we can have it going the other direction. So here I could have it, well, let's not go for red, let's go for a different color, let's go for green. So for example, it could converge to a number by starting high and then becoming this value here of x. So that's when it converges. Now diverging or diverges basically means that the sequence is either going to head towards minus infinity or positive infinity. So for example, if we had a positive iteration or sequence of un and n, then basically what happened is as n increases, so does the value of un, or it could obviously tend towards minus infinity, heading in the opposite direction. So if it's just only going to get bigger or only going to get smaller and smaller and smaller to negative numbers and then go in the opposite direction, then that's when we say it's diverging. Now oscillating, this is when values in the sequence go up and down repeatedly before converging or diverging. So this is when values aren't necessarily increasing, they're not necessarily decreasing, they kind of go up, down, up, down, up, down. So for example, an example of a sequence that oscillates, it could go like this before it eventually simmers down to this. So it's a bit like when you flip a coin. Obviously the probability suggests that you should have half 50-50 in terms of heads and tails, but obviously if you throw it 10 times that may not be 5-5 split. However, the more times you do it, the more that 0.5 probability tends to come into play. It doesn't always have to be along 0. It can let's say oscillate like this, or it could oscillate in the low regions in terms of negative numbers. It could go like this. So if you find that the numbers go big, small, big, small, big, small, big, small before either converging or diverging, so an example of where it would oscillate and diverge would be if your sort of sequence goes like that. And obviously trying not to mess with your notes by writing all over them. And then our final one is what we call a periodic sequence. So this is when the sequence produces certain values and then repeats on itself. So for example, if I had a sequence that started off 1, 2, 3, and then went back to 1, 2, 3, and then 1, 2, 3, then the repeated pattern would be those 3 digits. And we could say that this has got a period of 3. Like so. So if I had, let's say, a sequence that's went 1, minus 2, 1, minus 2, 1, minus 2, then again here this would be a periodic sequence or iteration, and that would have a period of 2 because there's 2 numbers in the repeated pattern. So let's have a look at some of these example questions. So in this example it says write down the first 6 terms of each of the following sequences and decide which of the sequences appear to be converging, divergent and periodic. For those that appear to be convergent, determine the limiting value for which they are tending. So let's have a look at working through these questions then. So for question 1a, just label this here, and again all I'm going to do is substitute the numbers into this. So we're starting with u1, which is 5, and then for this all we need to do is plug this in. Now in terms of doing this on your calculator, what I'd recommend that you do is enter 5, then press equals, and then for this what you do is you just replace the un part with ands. So for this what we then need to do is press 2 plus ands and then keep pressing equals to work out what the next term is going to be. So for this one the first term is going to be let me just have a look, it's going to be 5 obviously, then u2 is going to be 7, u3 is going to be 9, u4 is going to equal to 11, u5 is 13 and U6 is 15. Now as you can see that if I continue, so for repeatedly keep pressing the equals button, I would find that this is going to be divergent. So then picking another colour, so let's go for B. So here I've got UN plus 1 equals 6 plus UN. So U1, so again, all I need to do is press 6, press equals, and then it's going to be 6 plus ands. And then I get my first value, which they've told me is 3. The second value is going to be 9. And third one is going to be 15, then 21, then 27, and then 33. And again, that is going to be diverging because as n increases, it's just going to head towards infinity. For C, we've got UN 3 plus, it's virtually exactly the same. So the only thing here, it's going to be diverging clearly. But again, starting with a different value. So U1 equals 2. And then all I'm going to do is just add 3 to the previous answer. So the next one is going to be 5, then 8, then 11, then 14, and then 17. And again, that is going to be divergent. You can spell it. There we go. Then for D, here we've got again another UN in terms of 1 plus 2 UN. So here I'm gonna, my first value is 3. So all I'm doing is doubling and then adding 1. So double 3, add 1 gives me, and that's going to give me, let me have a look, 7. Then it's going to be 15. Double add 1 is 31. Double add 1 33. Double add 1 is 127. And again, that is divergent. In terms of our next one with E, we've got 8 minus 3n. So again, I can pretty much assume that this is going to be, again, going to be diverging. So I haven't really got anything special here. But let's have a look at what we do have. So in terms of this, our first value is 3. So here I'm going to do 3 times it by 3 and then take away from 8. So the next term is going to be minus 1. Oh, not minus 11. And then the next term is going to be positive 11. The next one is minus 25. Then it's 83. And then minus 241. And again, this is going to be oscillating because obviously it's getting bigger, smaller, bigger, smaller. So it's oscillating and to the point where it is diverging. Then in terms of F, so here I've got 10 take away UN where U1 equals 5. So all I've got to do there is just substitute the numbers in. So here I've got 5 and then I end up with 5 again, then 5, then 5, then 5, and then 5 again. And this sequence we can then say is going to be converging to 5. And again, you could say that this there is periodic with a period of 1. You can also say it's converging to 5 as it's just heading towards that particular value. Then looking at G, so again we've got UN plus 1 over UN. So the first term is 7. So the next term is therefore going to be 1 over 7. Then it's going to be 7, then 1 over 7, then 7, then 1 over 7. And again here, this is going to be periodic. Now this we can't say is converging because it's not tending towards a particular value. Now you might say it's oscillating as well, so it's periodic with a period of 2. You could also say it's oscillating, but again, because it's not either converging or diverging, I would say oscillating is probably not the best way of describing this sequence. Then in terms of H, so let's get and there. So for H, what we then need to do is substitute the numbers in. So starting with U1, we've got 2 over UN squared. So the first term is going to be 1, and then we enter that in. The next value is going to be 2, then it's going to be a half, then it's going to be 8, then 1 over 32, and then 2048. And this is going to be diverging as it tends towards. And then finally for I, which I'm just going to struggle in terms of space, I think we could just about fit it here. So for I, there we've got 2. Well, the first one is 2. Entering the values in, we get our next term, which is going to be 1. Then it's -2. Then it's 1. Then it's -2. Then it's 1. And how many terms we've got? Our 6. So for this, we can say that it's going to be periodic after the first term. So here, if I ignore the first term, you can see here that the pattern then does repeat because I've only got 1, +2, and the rest of the pattern then is 1, -2, etc. And again, that's got a period of 2. So let's just have a look at our last 2 examples here. So again, all we're doing is writing down the first 6 terms. So the first term is 2. And then finding out u2, well, that's going to be 2 over, and then it's going to be, now though it looks like un plus 1, it's actually going to be the previous term plus 1, which is going to be 2/3. u3 is going to be 2/3 over 2/3 plus 1. And again, the best way of doing these is just simply by using the AND function on your calculator. So for this, press 2 equals, then set up your fraction, and it's going to be ANDs over ANDs plus 1. So what you should have on your calculator is ANDs over ANDs plus 1. And then if I could just keep pressing equals, so I get 2/3. The next term is 2 over 5. u4 is going to be 2 over 7. u5 is going to be 2 over 9. And then u6 is going to be 2 over 11. And then it's just worth just highlighting where your answers are, just so that it's easy for me to mark. And obviously, in terms of writing this in an exam, I certainly would write it in a horizontal line. Then moving on to K. So again, our first term, u1 equals 3. So u2 is going to be 7 over 3 plus 3. And then just typing that into your calculator, but again, using the AND function. So 3 equals, and then for this, we're going to have 7 over ANDs, and then plus 3. How I'm entering this on the calculator is 7 over ANDs plus 3, and then pressing equals. So u2 is going to be 16 over 3, u3 is 69 over 16, u4 is 319 over 69, u5 is going to be 1440 over 319, and finally u6 is going to be 6553 over 1440. Now, in terms of this, one thing I'd recommend that you do is a common question asks, do we need to write it as decimals or can we leave it as a fraction? The question should specify, and if it doesn't, then I would leave it in the most exact form, only because it's a lot easier for you to write your answers. But similarly, it does tend to be quite popular where questions would specify to write your answers to 3 decimal places or 3 sig fig or anything of that nature.